Hello, my name is Chris Keyack with Keyack Technology Solutions. I'm a Tekla Structures trainer and consultant, and I do a lot of work with metal building clients. In this video today, I'm going to talk a little bit about creating shop drawings in Tekla Structures using our setup, and I do a lot of setup and training with clients who use MBS and use SlideRule to transfer information from MBS into Tekla Structures and create the 3D model. You can then create erection and shop drawings from the Tekla Structures model and use that for working with the shop. And here I'm going to actually go through cleaning up some of the different types of drawings in the model, and you can get a feel for what it's like to detail in Tekla, especially using our setup that we provide with clients. Okay, so let's go ahead and dive in. Alright, so I'm here in the Tekla Structures model, and the first thing that I need to do is go to the Drawings and Reports menu and go to Perform Numbering, Number Modified Objects. What this process is basically Tekla compares all of the assemblies and all of the parts in the model and looks at their geometry, and any of the pieces that are the same, it's going to automatically assign the piece marks and the quantities based on that comparison. Now once this is done, now I can start creating my shop drawings. Now there are two main ways of creating shop drawings in Tekla. The first one is just to go ahead and zoom in here and just select on a particular piece in the model. Then I can come up to, for instance here, this Create Fabrication Drawing command. When I do this, it'll open up a little bit of a dialog box, and it can show me that I can create assembly drawings, which is type A, or workshop drawings, or single part drawings of the parts that I have selected in the model. So W means workshop, A means assembly. Now if I don't want to see any of the part drawings, because I'm just focusing on shop assembly drawings, then I can just click this eyeball here, and it'll remove any of the type W drawings of the parts that I've selected. Now, I can then choose, if this is the first drawing that I'm creating in the model, which it is, I can then choose which save settings that I've created here to create that drawing, which basically these save settings have different rules for piece marking, callouts, and automated dimensioning on the drawing. So then I can kind of choose basically that setting here. So here, for instance, I've got some save settings called Bill of Material 3-plate assembly, which is part of our setup that is specifically geared for working with 3-plate assemblies like rafters and columns. So once I select that, I can press Create. Now when I do this, it's going to then create that shop drawing, and I'll go back to my document manager here, and this is where I can basically access all of my drawings in the model. So it's like my drawing list. Now here I can see that this assembly drawing has been created, and if I double click on it, it'll then open up the drawing editor, and then here's where I can actually start to edit this drawing. Now you're going to see that it's never going to be quite 100% exactly matching MBS, but there's a lot of rules in here that get pretty darn close. So what I can do is I can just see some of the different dimensioning rules that have kicked in here, and this uses some of the newer dimensioning rules that were introduced or turned on at least in the US environment in version 2022. Now here I can see, for instance, that I don't need those holes for those running dimensions to the flange. Here I can just grab on marks, and then I can drag and drop them. Here I've got two marks that are the same call out for just different holes here, so I can either just merge those, or I can delete these here if I just don't need multiple copies of the same mark. Now that duplication happens because there's multiple bolt groups in the model there for the holes in that cap plate or that flange plate. And then I can just drag marks around here. This is looking pretty good. I've got my overall, I've got my edge distances. This is looking pretty clean. Now, let's say that, for instance, here I need my diagonal dimensions on the outside flange. So what I can do for that is I'll go to dimensioning. I'll then just go in here to my add parallel dimension. And basically you pick 2 points here along the slope of that plate. And then I can just pick here, like right at the end and then the intersection and then middle mouse button. And then there's my dimensions. Now, again, I can just drag things to get them out of the way. And I know a lot of times on the MBS drawing it's going to show these as running dimensions. So I can just go click on these running dimensions over here, right? And then I can copy their properties in the properties pane. And then I can select on these other dimensions, press modify, and then here you can see that those dimensions have been added. Now sometimes when you have really short running dimensions here, the dimension's on top of the RD symbol or tail symbol. So I'm going to come down here, select individual dimensions, and then I can just drag that dimension out of the way. So now it's not on top of the RD anymore. Then I just got to make sure that I remember to come back down here to the lower left and say select all again. Now, because I do a web drawings usually, I don't have the dimensions to the webs, the slots and the holes. So it looks like there's some drainage holes on this particular customer's rafter. and column. And then there's also the slots here. And I just don't have dimensions there because I'm making a web drawing and all that information is shown there. And then this is usually burned on the plasma table. So really, mainly what I need to see on the assembly drawing is just to show how those show how those web parts are basically joined together and the orientation of those. Now, there is this dimension here, which I do have automatically turned on. I see this on a lot of MBS drawings. Honestly, I usually turn this off, but I do have a rule for it so that it does turn it on. In MBS, I believe it is going to the top flange, where by default here, I can't easily get it to the top of the outside flange. It goes to the top of the web, but you can just easily just grab the grip point and you can drag that to wherever you want to go. So you can have it either to the top web like it's defaulted, or I can just drag that to the top and clean that up. Honestly, I usually, for customers, turn this off because most of the times the shop knows to just transcribe the line down, and then basically they know that one side of the plate will align for the flange brace clip compared to, say, here with the Purlin clip up on the top. Now, I have some automated rules to basically skip over flange brace clips. So this is actually something I set up. That's why there's no running dimensions here to the AK307, for instance. And so just to explain how that works, if I double click into view properties, I've got some dimensioning rules here. So if I go to dimensioning, I've got basically this clip running dimensions, and it's using a filter dimension. So usually I don't have clients have to come in here and set this up. I set this up with them or in front of them when we review some drawings. But here I'm using this filter called MBS Clip Dim. And that will basically pass creating what things will have running dimensions to them on the drawing. So if I go to the filter, I'm going to go find MBS Clip Dim. So if I go to that, you'll see here that I've created a filter that says, hey, do dimensions to anything called clips, stiffener, or plate. And that is not, has no UDAs for flange brace clips. Now, sometimes that doesn't work because I think end-wall Rafters do not actually have this flange brace user-defined attribute from SlideRule. So then most of the time for customers, I actually just put in their standard clip mark. So in this particular customer's case, it's AK307. So I just put that rule in here that as long as it does not equal these, then and it does equal clip, stiffener, or plate in the name, then I'm going to create running dimensions. And that's why we see the running dimensions to those, including the stiffener and these clips, but we do not see that for these AK307s. Okay, so here we can also just drag this across if we want to. And again, you'll see that it goes to the top of the web. So I can just drag that up on the top if I need to. And there we go. Now we've got that set. Now over here, sometimes I'll just bring in the hole dimensions. I like to see the overall on the outside of that, just from a detailing practice and standard point of view. But honestly, I'm getting pretty close. This actually is a really clean column. Looks pretty good here. Sometimes I'll see that people will want a running dimension to this particular hole here from the left end of the assembly. And so again, I can just click on this dimension to apply its properties as a starting point or an example. And sometimes on the MBS drawings, I see this particular dimension go from the end of the base plate versus here, the tails like on the actual flange. So maybe I'll just do that as an example so you can see where you set the origin. Then I can go right here on that intersection, middle mouse button, and then there is my running dimension placed for locating that particular, that end plate from that hole from the bottom of base plate. So there we go. We've got all of the dimensions that we pretty much need here to probably kind of initially set this up. I might want to add an additional dimension here to maybe locate this to the flange. So again, if I need to do that, I'll just come in here and I can either add that dimension. So watch this. I'll just right click and say add dimension point, go to that top there, and that gives me that. Again, I just kind of need to deal with this running dimension overlap there. So there we go. We can add that, or I could have just added a string dimension to maybe the hole. So let's show you how to do that. Now, I don't want to do running dimension for that. So watch, I'm going to click on this dimension here, again, to use its properties. And then what I'll do is I'll just go up to dimensioning. I'll do parallel dimension here, and then activate that command. I'll pick 2 points along that line. And then what I can do is I can pick right here at the hole and then pick right there on the corner point of that middle mouse button. And there we go. It looks like it didn't apply, so no problem. I can click on this dimension. I can then go ahead and do the paintbrush here, which will copy the properties. I'll select on that dimension there, and then I can say modify, and then there's those dimensions to the hole. So there we go. We have 2 different ways of locating that plate. Usually it's going to be to the hole, so maybe I'll just come in here and delete out this 8 5/16 dimension. Now I want to make sure that I turn my selection down here at the lower left back on, so I'm not just selecting individual dimensions, but I can select all objects. And that's a pretty good starting point. I think I got everything I need there to basically have that drawing. The last thing I'll probably do here is I'll note that I've got my weld table. If you don't want to use the weld table and you've got weld standards, no problem. I'll just double click on the drawing in the background. I'll go to view creation here, layout, and we'll turn this from assembly 11 by 17 to with the weld table to turn that off and just say modify. And there we go. Now we just have that drawing there, and the weld table is not shown. Last thing is we're going to go ahead and cut a section. So if we just come up here, we'll go to views. I'll then go to section view. I'll then go to the view button here, and I'm going to load up my RF section settings. So now I'm going to go ahead and just pick right here as my first point of my section line, second point, then this is the depth and the direction of the view, the depth in the other side or the other direction, and then I'll pick to locate where that section is going to be. Now, here I've got some welds basically shown because this pretty much matches what you see a lot on a lot of MBS drawings. So I'm just going to take these off. But if you, again, just had weld standards, you could delete those welds off there if you don't need to see them. So here, if I've got like welds on both sides, I don't need to see that, so I'll just delete those. These are exactly the same welds, so I'll right click and merge those and just drag those up. And then here, I don't typically show my flange or web marks in here. I'll just show basically the clip marks. And if you hold down Shift, you can actually drag the mark and the leader line around at the same time and just kind of move these around. So there we go. And sometimes I don't get the dimensions on the bottom clips for some reason, but this looks pretty good here on the top. The only thing I might need here is maybe the overall. And I'm probably overkilling it here with the dimensions because this is a standard clip and I tend to not over dimension standard clips. I mainly need to show the shop how to orientate this, but I'm just trying to match kind of like the MBS drawings. Again, if I need to manually place any dimensions, say for the clip, I can just pick these 3 points here and a middle mouse button to place it. Maybe I'll put an overall there. Middle mouse button, do a vertical dimension. So there, to the bottom, middle mouse button, there to there, middle mouse button. And that kind of pretty much shows you how easy it is to add those dimensions. All right, so now that I've got that all set, I've got basically all the information that I need there for the shop to do that in that section. And then I've got everything else shown here, and I'm pretty much all done with that main rafter assembly drawing. Okay, so when I come back out here to the Tekla model, the second way of creating drawings is by selecting on the part and going to the master drawing catalog. And here I've actually got a set of rules created that will use filters in the model to automatically detect different assembly types, and it will automatically create the shop drawings for either selected parts or all of the assemblies in the model. Now, basically what I can do is I can select either my MBS assembly drawings or the assembly drawings reverse. The reverse is basically just going to draw the cold form shop drawings for like your girts, purlins, jams, and headers. It's just going to draw it from the back of the web. So that way the flanges are towed away from you. If you want the webs for your cold rolled and cold form towing towards you, then you just use this first rule here. And then for single part drawings like individual end plates, webs, and flanges, and clips and stiffeners and stuff like that, we can use that to create those workshop drawings, which we're not going to focus on here. So here I'm just going to go ahead and use the reverse because this is pretty common. This is what we usually see. Now I'm not creating any cold form just yet, but I just want you to see that I can select on this here, and then let's just pin this to the top, and then I'll right click and say create drawings. Now what it's going to do is it's going to go ahead and create 2 additional drawings on top of the original assembly drawing I had. Now I already created that drawing here, that 3-plate assembly drawing. That's what you saw me just cleaning up before. But what this master drawing catalog does is it makes an additional set of 2 drawings. One that's the weld drawing as well as the web drawing. So here I'm going to go ahead and take a look at the web drawing. So basically this is where I start to put a lot of my dimensions in here because this is pretty common from metal building detailing where they have a specific just web orientation and placement drawing. Now you'll see here that there's when you have a lot of extra holes like the drainage holes, then you might have like a little bit of extra dimensions that you need to kind of tighten up and move, and I've just got separate running dimensions here to those, so I can just bring those in, tighten them up a little bit. I can move the slot marks around, and then here over on the right we can just tighten up some of these dimensions, just move these around. Otherwise everything looks pretty good. And I tend to, sometimes I actually probably have too many dimensions on the main orientation drawing, because what I often do is I'll create separate single part drawings, which I'm going to show you what I mean by that in 1 second here. So let me just tighten this up a little bit, bring those in. So when I bring those in, what I can do is once I've got like kind of like all these additional dimensions here, I probably need a rise dimension. Again, this is going to be, again, probably adding too many dimensions on this specific main view up here on the top. Here I can probably just do these top views here, these dimensions. So I'm manually probably spending too much time dimensioning that because it's going to be on these two additional plate views I'm going to do on the bottom. But once I've got those dimensions cleaned up on the top, I can click on the background and then right click and say Arrange Drawing Views, and then that'll rescale the drawing to fit it better on the sheet. So I get a little bit more fit on there. Now when I click on this gray border, that's the view or basically the view border of that particular view on the drawing. Then I come up here to the contextual toolbar and I can see that the scale right now, that is 20. Now what I'm going to do is I'm going to select on the two webs and right click and say Create Single Part Views. And that adds a couple of views here of just the individual plates. And it's got a lot more dimensions, including like the bevels. So that's why I was saying that maybe I was adding too many views up here on the top, which this is primarily for the purpose of just showing the orientation and which web goes where on the assembly. Now, on these inside views, I'm going to go ahead and click on these, and then I'm just going to go ahead and come up here to the contextual toolbar, and I'm going to change the scale to, say, like 24. So when I do that, it's a little bit smaller scale than what's actually shown in the main view, so that way I can fit these side by side, which gets pretty close to what you would see on a traditional web drawing coming from MBS. Now you get, when you got all these like kind of drainage holes, you're going to see a little bit of like extra dimensions here for all these holes, and it gets a little bit tight at this scale, but you'll see that the bevel is there. You've got the hole callouts, all the dimensions and everything that you need for the plate are all shown here. So it just might take a little bit of cleanup to just move some things around, but you have all the dimensions and everything that you need. And then you can see here that this is an oriented bevel. Now this is going to usually all be burned in the shop on the plasma table. So I don't know if all these dimensions are necessarily always needed these days, especially because it's going to be numerically controlled from the model and sent to a machine in the shop, and it's not hand laid out anymore. But it's there for QC and reference purposes as required. So then I can just drag these dimensions down, and again I have all of the dimensions there that I need. And sometimes I get a little bit picky here as a detailer and I bring that in, the whole dimensions inside from those cut overall dimensions. But there you go. Within a few minutes, I've got my web drawing. I can then close this down, mark it ready for issuing so I can keep track of the drawings that are cleaned up, and I'll move on to the weld drawing next. All right, so now I'm going to go back to the document manager, and I'm going to go find my weld drawing here, which is this third drawing. So this is an optional drawing, and I just show this because it depends on what type of customer you are. I usually have this drawing created specifically for AGT customers who have an AGT robotic welding machine, and they want a QC drawing to see all the welds that are coming from MBS through SlideRule into Tekla, and they want to validate that and verify that against their shop standards and see exactly what the AGT machine is going to be doing. Now this is one drawing, and I will say this is why I also pull the welds over here on this drawing versus show it on the main assembly drawing. I can absolutely show these welds over on that drawing, but then it just gets a bit congested and has a lot of weld symbols that you got to clean up and overlap with the main assembly drawing and all the part marks and dimensions. So I just decided to pull this onto its own drawing by itself. Now, because of the fact that I'm using polygon welds in the model, I'm going to get a lot of extra welds. Like here, there's actually two weld symbols pointing to what seems like the same location on the shop drawing. But in reality, what's actually happening here is there are two physical welds, one on the near side of the web for the flange to that end plate or the base plate, and one weld on the other side of the web for the flange to the base plate. And so this is needed for the AGT, but it's not necessarily needed for shop drawings. And in some cases, you might have a near side, far side weld, but you're going to see these individual weld symbols showing single near side welds. So my point here is that if there's duplicate welds just for drawing purposes, I can just delete one of those welds out, or you can also select on any welds that are the same and do merge, and it'll combine those into one weld symbol. So here I can just move these around and then just get this so that way it's orientated and pretty clean. And then here I can just use the arrows. So that's the only disadvantage when you merge the welds, is that if you kind of change one of the arrows, it doesn't do it on both of them. So there I'll just delete one of the welds, grab the grip point here at the middle of the leader, and I can drag it down, and there we go. Now, I'm kind of torn here on the welds showing every weld at every clip, even though these are exactly the same. So this is kind of typical. So you could delete one out just to clear up the drawing. But again, if this is for QC purposes and showing the guy out in the shop for the AGT machine what's going on, then maybe I'll leave those there. Same problem here. I've got a near side, far side weld. So it looks like there's like a whole bunch of welds going on here, but really it's just that there is a near side, far side weld based on this client's standards, and they're welding both sides. And so, again, I could merge these weld symbols here, or I could have turned that into, basically a near side, far side weld symbol, or just do this here where I'm dragging this out. But, again, this is for, it's not necessarily super pretty, but it shows the intent of what's going on with the welds. So same thing here, like I may not clean this up in every case, because it just costs time to do this. And so this is the one drawing where I'm like, hey, this eats up a lot of time. Here when I'm looking at this, this is again pretty congested, and this gets to be like kind of a lot of stuff going on. I'm not going to spend the time to clean this up, but I did want you to see that, hey, this is the reality of the situation of showing welds. And when it gets more congested and you've created individual welds for the AGT robot versus kind of combining welds into a near side, far side symbol like you would normally in the drawing editor and just saying typical, then this is kind of some of what you have to deal with. And I don't want this to necessarily scare people off, like, hey, that Tekla's not good at this. But again, it's more that I'm trying to communicate that from a robotic welding machine point of view, a lot of customers are like, hey, we want to show all the shop drawings or show the welds on the shop drawings, but we're also using a robotic welder. And there's unfortunately a trade-off. In order to get all the individual welds in there to feed the machine really well, it's not going to be very conducive for showing those exact welds on the drawings without a lot of cleanup. So I tell people that, hey, still use your weld standards, but we're just going to try to get the welds in the Tekla model to match those weld standards. And then, you'll still have the same procedure like you have with the weld standards, and don't show a ton of welds on the shop drawings, but we'll have the correct welds in here and in the model and coming through DS Weld from MBS into Tekla to match as much as possible those weld standards, so that way the AGT machine is doing everything correctly. Okay, so now I'm back in the model. I'm going to go to the document manager, and I want to see which one of these assemblies in the model that this drawing actually covered. So if I press on this select model objects, it'll then highlight all of the objects in the model associated with that. So here I can see all of these particular assemblies, and it looks like it's all of the columns on this building. So here it looks like it took care of everything, and I didn't have any different piece marks due to anything going on in different corners of the building, and all of my columns for the main rigid frame are all taken care of. So the next thing would be to go ahead and select on a rafter and take care of that. Now the other thing I can do here is I can go ahead and just create all my shop drawings at one time. So what I'm going to do for that is I'm going to come down here and I'm going to go to a selection filter, and I'm actually just going to come in here and I'm going to go to MBS shop drawings. So I've got a filter, see MBS shop drawings, and I've got MBS shop drawings by name. If I do MBS shop drawings, look at the filter. Basically, this is filtering by certain profile types that I know I want to make drawings for. So this is going to be plate, like HSS, hot rolled channel, things that are that you typically want to make drawings of, usually the primary frame. That's one way of doing this. The other way is by name. So if you're more accustomed to like, hey, based on the MBS piece kind and the types of assemblies that I want to create drawings for, you can basically check or uncheck the different assembly types that you want to make drawings for. So some people don't need to make their bracing drawings for their cable or their rod bracing, so they'll uncheck a brace roof or brace wall, and then it won't make any drawings for that. So we could uncheck that if we wanted to, and then we can just say apply and OK. And then now if I window around the model using that filter, it's going to select everything, but it will exclude our cable braces. Now you may exclude like your Girts and your Purlins, depending on if you're doing welded clips or not. So here on the jams and the headers, I've got a lot of welded clips going on, so I'm going to need to make shop drawings definitely of the jams, but maybe I don't need to do that of the Girts or the Purlins. So you can choose to control what things that you want to make the drawings of. Now, another methodology that I sometimes tell people is, rather than worrying about those filters and then maybe accidentally missing something, one strategy is I just tell people, hey, go to the master drawing catalog and then select on whichever assembly drawing rule that you want to use. And I tell them, hey, create drawings for all parts. That's going to create drawings of everything in the model. But you know what? It's better to be safe and have all the drawings created and then just delete the stuff out that you don't need. So if you see panels or Girts or Purlins and you look at the drawing, you're like, hey, I don't need a drawing for this. My cold form report or my shipper is going to take care of this. Then you can just delete those drawings afterwards after they've been created. So here I'm going to just go ahead and say create drawings for all parts, and then it's going to go through and make all the drawings of all the assemblies in the model, and then I'll just start going through the list and cleaning those up. Okay, so now that the drawings are done, I'll go back to my document manager, and if I just sort by, for instance, mark, I can just see all the assemblies based on their piece mark and just start whittling through the list. Now, I'm just going to go through a couple of different types of assemblies so you can kind of see how this works. The first thing would be is that maybe I've got like a standard loose clip here. So I've got AK241, and I think I know where this is. This is on the end walls. Yeah, so this is this end wall kind of bracket or bent plate, and actually I would probably change this out for an angle instead. But here you can see that this is just a standard drawing, and if it is a standard clip, then maybe I don't need to make a drawing of this. This is probably just going to be in my shipper. So if I go back to my document manager, this is one of those drawings where I may decide to just delete it out. So I'll just delete that. Now, then I've got some, looks like plain material for my base angles and potentially my rake angles here. So let me just open that up and see if that's what this is. And yeah, it looks like it's just some simple, angle 4x2, probably gauge angle here. And this is something that is kind of like more like trim and just a standard length. And I could probably just show this in my shipper, and I don't really need to make a drawing. Now, just from a detailing philosophy point of view, if I'm an inside detailer specifically working for a large metal building company, then I tend to just follow the procedures of having like my reports and shipper handle a lot of just kind of standard plain material. But however, sometimes if I'm an independent like kind of builder in the builder network, and I'm using Tekla and I kind of sublet things to a metal building company for the manufacturing or fabrication, sometimes I tend to overdo it just to be careful, especially if I don't know all the inner workings of the setup of Tekla. Sometimes a drawing can speak louder than the reports, or I'll still make the drawings anyway, even though it costs me a little bit of extra time to make these drawings and clean them up. I still might have the drawings to accompany the reports that I run just to prevent any kind of confusion or misfabrication by the manufacturer, so they can see exactly what I'm intending to give them based on what's in the 3D model. That's kind of up to you. So I'm going to close this down. And again, if this is just some plain material and I know what these are like, based on the piece mark here, I know what those are in the profile, that those are just kind of my base angles and stuff. This is probably going to be covered by the shipper. So again, I might delete those out. Same thing here with braces. It looks like this is cable braces based on the piece mark, so CB. And I didn't do any setbacks here. So this is the fab length of the assembly coming across from MBS. I didn't really put in the cut length setbacks and the hardware on the end of this. Sometimes I do that and make a drawing. But again, I usually just cover this with the shipper and just say what the fab length and the cut length, if I do the setbacks, cover that. And then most manufacturers know to put the hardware on that. It just kind of depends on what you need there. And then I'm just handling that with the shipper. So again, I just come in here and delete some of these drawings out that I don't need. Now, this, again, I've already got those filters. You saw that before, that I have the shop drawing filter, so I can prevent any of these types of drawings being created. I just do this for new users to show that, like, sometimes just to be safe, just create drawings for everything. And if there's just, so that way you make sure I don't forget anything. And if there's just stuff that you don't need drawings for, you can easily delete it out if the master drawing catalog did create it. But you can also use selection filters and even set up the master drawing catalog to not create drawings for certain things. But you just definitely want to make sure that your filters are completely 100% working, so that way you don't miss anything. Okay, so let's start to take a look at some cold formed here. I've got a door header. So let's go ahead and take a look at this. This particular customer is a welded clip customer. So instead of doing bolted, they'll weld some of their clips to their headers and their jambs. And this looks pretty good. So there's no punches, so that's why there's no punch code shown in here, but I can see the section. It's a little bit misleading what's going on here because I can see that this is drawn, and when you look at the section, the clip is actually supposed to be far side, but because the MBS and SlideRule is actually bringing this into the Tekla model as flush, and I think they do this for dimensional purposes, for the running dimensions on the jambs for where the holes are located and the opening size. But it's a little bit misleading, and this probably needs to be changed to a hidden line. And it's not being drawn as a hidden line, even though it is going kind of far side, like towed away. And so to quickly just change that, I'll go over to the properties pane and switch this to hidden and just modify that. And then that way it looks a little bit more correct. Normally, if that was truly like not like centered on the material where it's flush, where there's a small clash there, if that was actually down farther, then that would be drawn far side automatically. But just due to the nature of how SlideRule is kind of bringing that in, that's why it looks like that. And again, maybe I'll come in here and I'll just select this individual dimension, bring that down. I'll probably add like the individual dimension on this as well, just to show both sides. I'm assuming that the shop kind of understands that based on the overall dimension that they need to kind of keep that 3-foot dimension, and then they see the cut length of the actual cold form piece there. Here I might not need this additional dimension, so I might take that out and just show the offset from the back or the control dimension. And again, that's a little bit off because it is going to be a little bit more like 2 1/16 there in real life because of the gauge on the material. But basically, you kind of get a feel for whatever dimensions and things you need to add. I do have the weld table and the welds turned off. I could turn them on, but this is gauge, so I just assume this is kind of a simple standard weld covered by the weld standards, and that's why I don't have that shown here. But there you go, just a couple of minutes of adding additional dimensions. Here there's this running dimension here, so I might get rid of that. And again, just you have your overall length or this kind of out to out and these 1/4 inch dimensions to kind of show what's going on there. It's kind of up to you what dimensions you need to show. But I'll close this down and I'll just say mark ready for issuing, and then let's go to the next drawing. Okay, so let's go ahead and take a look at an Eave strut drawing here. So I'll just go to this E1, and in the drawing editor, the first thing that I'm going to determine is which way do I want the drawing drawn from. So in this particular case, because I used the reverse settings in the master drawing catalog, it is drawing the Eave strut towed away. So if you look at the sections, you can see that the flanges are towed away. And then the punch codes are going to also be displayed accordingly to that. Now I did look at the DT punch that came across from SlideRule on this, and this customer does not have a marker for Eave struts, so that's why I got question marks for the punch codes. Now, basically what I can do is if I double click, if I did want to change this so that way it was towed the other direction, if I'm just matching like the bill of materials and the shipper from MBS for the punch code direction, or the fabricator tells me that, hey, they want it towed the other way instead of the reverse, what I can do is I can just come up here to the save settings and I'll just go to BOM, cold rolled. So I can just go ahead and choose that. And then basically what that'll do when I modify is it's going to draw this instead of reversed, it'll draw it where it's towed towards me or towards the near side. So you can choose either option. So I'm just going to go ahead and undo that. And what's basically adjusting that is really this rotation over here. But the other thing to be careful of is that not only am I changing the orientation, like swapping or rotating the views around the x-axis, which is along the length, or the y-axis in the middle, but the other thing that I'm doing is in the actual view properties themselves. If I go back here to view creation, I have like a face cold formed, and then I think I have a face cold form reverse. And the reason why there's two different settings is because the punch code template mark will be reversed depending on which of these two settings you're using, cold rolled or cold rolled reversed. But there you go, get kind of an idea of how you can use the setup that we've built, and depending on which way you want to draw the cold form, you can control that. And then looks like here I can just kind of delete some of these extra dimensions out. That's just because there's been separate bulk groups here added, and then we can maybe remove this dimension. I probably wouldn't remove that. This is a pretty standard pattern here, but typically you don't dimension out to that other leg there. But there we go. So that shows you what's going on there, and then I can just go ahead and mark that ready for issuing, and let's go to the next drawing. Okay, so let's take a look at some very simple cold form pieces like Girts. So I'll just go ahead and go to this Girt, and let's see what we get. Yeah, pretty basic. So maybe the only thing I see here is maybe the overall dimension just needs to be dragged down. Punch codes are coming in nicely. This is a Z profile. And again, based on the reverse setting, you can see that the top flange is towing away. And again, if I wanted to change that and have it towed the other direction, I can just use cold rolled here. And so there's cold rolled reverse and cold rolled. There's also a cold rolled from back. And I use that sometimes on jams, where I do want to be looking from the back face, but I don't want to actually rotate it 180 degrees around the Y. I just want to kind of flip it upside down around the X. And that oftentimes happens on jams because you want the base plate towards the left or the bottom of the building. So there is another option there in case you want to do that. But this looks pretty good. Not really much to clean up there. And so I'll just mark that ready for issuing. And then let's go ahead and take a look at a Purlin drawing. So I'll go back to my document manager, scroll down here, just look at for a P drawing. So let's take a look at this. And when I open this up here, all right, so a little bit more going on, but again, the punch codes. So it looks really good. Again, top flange is towed away. So I can validate the punch codes on these drawings and check that against the shipper from MBS and just make sure that, hey, like, is this towing the right direction? And is for this particular piece mark, if MBS won't make a drawing of this, is the shipper reporting this the right way? If it does have welding on it or it has something non-standard, then MBS will make a drawing, but it won't, unless you tell it MBS to specifically do this, it won't by default usually make drawings of cold form that don't require drawings because the shipper will take care of that. But that's my way of confirming to make sure that everything in Tekla is matching the output from MBS. So if I send this out to the shop and to my components manufacturer that does all my secondary and cold form, that I know that I'm not sending them bad information and that everything is correct. So, maybe I would clean this up and move this out of the way. It's going to be masked when it prints out, so I don't have to really worry about that. But this looks pretty good. Not really much to clean up. Close this, mark it ready for issuing, and then we can move on to the next drawing. All right, so let's go ahead and take a look a little bit closer here. We've got maybe an end wall rafter I want to look at, maybe the main rafter here on the 3 plates on the rigid frame, and maybe this hot rolled column. Let's start with the hot rolled column, see how that ended up coming out. So this is a W12. Go to the document manager, and if I actually have something selected in the model, I can find which drawing that's on by pressing this button here at the top of the document manager, and then it filters the list to that specific one. So here, EC1 makes sense. It's an end wall column 1. So we'll go ahead and open that up, take a look at how well it did. Not too bad. This is actually using the old integrated dimensioning settings, and what that I probably won't explain that too much here, but it just means it's using the old-fashioned style, out-of-the-box, conventional steel type dimensioning. And this actually doesn't look too bad. I might, move some marks and things around here. Got the slots. Probably a little bit of overkill of adding, dimensions on all faces and stuff like that. So I can kind of see this. Now, one thing that is going on here is because it's nice and clean in that it's a hot rolled piece, there's no taper. You'll zoom in really tight and there's these kind of like breaks or break lines or gap here. And this is caused by the shortening. So if you look at this, this is 22 foot long, but I'm fitting this on an 11 by 17 drawing. And what Tekla has for hot rolled members is that if you basically have these pieces here that are really long and there's a lot of white space and distance between the clips or bolts and holes in the member, then what Tekla will do is it'll shorten or truncate that extra white space out to get a nice larger scale view of that drawing and that assembly. So it looks a little bit cleaner here on the drawing. This doesn't look super good on 3 plate, and I'm going to show you why when I do the rafter and kind of some of the trade-off that you need to deal with that. But this looks really, really good on hot rolled. So watch this. If I double-click in the background, this is my master drawing catalog rules are using bill of material hot rolled for interior columns or end wall columns. And it just looks really good. The dimensions are really clean. There's actually really not a lot that I probably would do on this. Now, if I did get like the rafter is probably going to look pretty rough, so I'm going to show you that here in a second. But if the integrated dimensions are not doing really good and like over dimensions and does a lot of skews, and it tends to happen a lot on end wall hot rolled rafters, then instead of using the hot rolled integrated, sometimes I'll just use the bill of material hot rolled. So when I do this, it uses a different set of view properties here, and so I'll just say modify on that. And look at that, a lot less dimensions, right? So less views, a little bit less dimensions. It even has like the dimensions in the main part itself, because I oftentimes for hot rolled will just make a single part drawing of this, which has all those individual hole dimensions and slot dimensions, and it keeps the assembly drawing a little bit cleaner, kind of like what I did on the rafter earlier. And then let's just arrange drawing views there. There we go, it looks pretty good. So this has a little bit less dimensions, a little bit cleaner. So this is kind of, again, dimensioning this more like a rigid frame member a little bit. But you just need to kind of determine which style works better. So let me just undo this back to how it was. And you can kind of compare and choose whichever one that makes more sense. So again, there's bill of material, hot rolled integrated, and then there's hot rolled. And this uses the integrated uses the old kind of conventional steel dimensioning style, and the hot rolled uses kind of the newer dimensioning style, which has a lot less dimensions on the drawing. Okay, so let's go ahead and move over to a end wall rafter, and this is a cold form rafter. Okay, so let's see what Tekla gave me. Let's see what my master drawing catalog chose. So I'm going to remove this filter from the document manager, and I'll select on that end wall rafter, and I'll filter for that. And it looks like cold rolled assembly settings were used, so let me just open that up and see how that looks. So when I come in here, there we go. So this is the kind of stuff that scares people. When you don't have my setup and good save settings as starting points, and you use out-of-the-box Tekla US settings that are designed for conventional steel, things get a little bit out of control. So for Girts and Purlins and jams, things with no connection clips, especially skewed parts, the integrated dimensioning does really good. And that's why I have my cold rolled settings using those dimensioning styles. And this is a rafter though, so this isn't something simple, and it's got a bunch of skewed parts on it, and that's why this kind of looks a little bit trashy and kind of a chia pet of lots of different stuff. So this is where it makes sense to double click in the background. And instead of basically using this cold rolled, then basically what I can do is I can either use the hot rolled settings that I've created. So like here, if I just go down to BOM go up, let's see, let's use hot rolled and not use the integrated dimensions. And I'll just say modify on this. And then it's going to make it kind of look more like a rafter, right? So even though it's a cold rolling piece, I want it dimensioned in a style that's a little bit more close to a rafter. And the only thing that I might come in here is I might change on the title that, this isn't really a hot rolled assembly. So I might say that this is cold rolled rafter. And then I could, save those settings away up here at the top if I wanted to, but I'll just modify that for this particular drawing, press OK. And then now what I need to do is just add any kind of additional dimensions or move things around. So here, again, because I've got the dimensions for the main part usually on hot roll turned off because I make single part drawings of that. If I do need those just quick running dimensions, I can just add those, middle mouse button, and then those dimensions are there. Again, if I want to make those running dimensions, I select on this, use the paintbrush, select on this and modify. Okay, so there we can see those running dimensions. And then if there were any other dimensions kind of on this piece, I could do that. Looks like I got one more here. So let me just do that on the bottom. So just do that for that there, middle mouse button, and there we go. So we've got that dimension. Now, the other thing I tell people, and I've got this in my setup documentation, but there's a little bit of trade-off with this kind of new dimensioning style. You can't get it to do the bevel dimensions and stuff really good on skewed parts and find the contact. It just kind of goes to the left face. So no problem. I'm just going to click on this grip point and then drag it up here to the contact point. And sometimes you got to be a little bit careful there. But there we go. There's the contact point for that. And I can drag that down if I need to. And then same thing over here. I just kind of grab these points that are offset a little bit. Just move those. Sometimes the drag doesn't get exactly where you want. So you just kind of move that until you get it where you need it. So let's move that off. Back to there. There we go. And, it's looking pretty good. And then here I've got all my dimensions. Sometimes this gets a little bit froggy of trying to kind of locate this. Like it's trying to do a centered dimension here. And really I want that to the hole. So I just drag that point. I can then bring this up. If you want to flip that dimension to the other side so it's not overlapping with the part, you can just right click and say flip outside dimension. And that's looking pretty good as well. 2 running dimensions here. Not quite sure why that anti-roll clip or whatever is not going right up to there. To look at that in the model, but I'll just right click and say remove this, and usually just that dimension to the clip, or sorry, the other dimension. So I'll undo that. And if you select on something and you just want to get rid of one of the dimensions, you can come in there and click on that and it'll get rid of that. You can also add dimensions that way. So you can add an additional point like there. Okay, so I'll undo that. And I've got my dimensions to my stiffeners. So, this is looking pretty good. Like I've got just about everything there. I probably need to cut a section just like I did on the other column and rigid frame rafter drawings. But this is looking pretty good. And the main thing I wanted to convey in this part of the video is that sometimes the cold rolled settings or hot rolled integrated, that is not going to work. You're going to get kind of overkill in the dimensioning using the conventional steel dimensioning settings. So I just switched that to this hot rolled type, and it's going to use more settings that are similar to like a rigid frame column or rafter and be a little bit more minimal in the dimensions, and you just have to tweak a few things like you see here. Okay, so let's go ahead and finish up with the rigid frame rafter here. If I select on this, pretty decent length, the rafter, just one single rafter for the full slope or the half side of the building. So I'll select on this here, and then I'll just go to my document manager. Let's filter and find this particular assembly. And there we've got our 3 drawings, just like we saw in the column. I'm going to just focus on the assembly drawing. So I'll double click on this and go inside of there, and we'll take a look at what we get. Now, when you first see this, there's a little bit of congestion going on. There's quite a bit of stuff here, but what it is that it's these darn flange brace clip dimensions, and it tends to kind of, using the integrated dimensions, tends to over combine these. So rather than splitting those all up, like I said earlier, I tend to not have this on. I just did it because a lot of people ask me about it, like what it shows on MBS drawings, but most shops in reality, they don't need this, and they just kind of scribe the line down. So what I'm going to do is I'm going to show you how I get rid of that automatically, so I don't have to delete it manually. I'm going to double click in the background, go to view creation, and my RF assembly main view properties are what's controlling the dimensioning. I'll go in here to my view properties, and then I'll go to dimensioning, and I've got a rule here that says holes flange brace Y. I don't want that anymore. So I'm just going to go ahead and delete that out. Then I'll hit save here, and then now I'll close. I don't need to save anything here because nothing's really changed on the name of the view properties being used, so I don't really need to save this away. All I got to do is come down here and say recreate the drawing to yes, modify, and then here it's going to get rid of that dimension. So it just takes a little bit of congestion away, and there's a couple more things that I need to add here. But I also have, like I said earlier, I have web holes turned off because I usually show that on the web drawing because a lot of customers ask for that anyway. And so just to keep things cleaner on the main drawing, I just have those off, and then they just look at the kind of where the slots are to figure out the orientation. And again, they're going to use the web drawing for that. So I'll bring this in a little bit tighter up here, and then maybe I'll flip the dimension. So just right click, start moving stuff around. Now, the first thing before I start spending a lot of time cleaning up, you got to be careful with this, right? And also let's say I got weld standards here. I'm going to turn this, let's turn this setting off here under layout to turn the weld table off. So I'll just modify that, get that done first, right? And then in that particular case where I did turn the drawing size to a different layout where I'm not using the weld table, that is where I do want to press save here on this setting, since the master drawing catalog calls it out, and put that in my firm folder so I don't have to worry about changing that again in the future. Now, before I do anything else though, okay, before I start cleaning all this up and spending any more time on this, what I want to do is I kind of want to look at this and go, all right, well, it's a pretty long Rafter. It's not really super long. I've even seen longer than this, but it just feels like it's a very thin Rafter and the scale isn't like working out well. So what am I talking about with this? If I click on the view border and go to the contextual toolbar, it's got a scale of 32. Right, so 1 inch to 32 inches, and so that's a little bit small, and it might be a little bit hard to see for the shop. And this is just unfortunately kind of the nature of working with 11 by 17 shop drawings, and not having any shortening, like where we saw in the hot rolled member where it actually shortened or compressed the member and took some of the extra white space out. So first of all, let me show you what it looks like when you shorten a three plate member in order to get like a better scale. To do that. And if I just want to do that specifically on this one view, I can just double click on this. It'll open up the properties, and I'll go to the attributes tab here. And on the attributes 2, there's this ability to say cut parts. So this is one way to get to it. And let's say I only want to do that in the X direction. And I'll even set this shortening distance to be really small. So that way it really tightens that up. So I'll just modify that to like 6 and say, okay, and look at that. It gets really crazy. It like shortens this up quite a bit. Now when I do that, I can right click and say arrange drawing views, and I'm surprised it didn't auto scale this to be a little bit better. So let's even change that. If I select on this view and then change this scale, maybe I'll drop this down to like 16, hit enter. There we go, getting a little bit better. Let's get to 12. There we go, look at that. See, with that scale, or with that shortening, I can fit this a much better, nicer scale, and this looks a lot better size-wise vertically. But here's the problem. Is it puts in like this stair step, and this confuses the shop. It kind of takes the context of that this is a tapered member, and it kind of makes it confusing. And then I've seen where this gets released to the shop, and then the shop asks like, hey, what is this? Okay. Now the first thing is you can actually put break line symbols. There's settings in Tekla. So if you go up here and you go to settings, advanced options, and we just look for shortening in the search. Let's see if I spelled that right. I typed it pretty fast. But there's this shortening symbol here, and shortening color, and shortening with zigzag. And you can turn these settings on and kind of modify this so that way it actually puts like break line symbols there. And that's a little bit less confusing for the shop so they can kind of understand what's going on. But again, if you make these shortening a little bit too tight, so let me just go to properties pane here. And this is another way to get to that shortening. See how here it says only in X direction. Let's change this maybe back to 12. Okay, so now I can't fit that with 12. I can't fit that scale, so no problem. I'll just come back in here, go to the scale, switch this to 16. There we go. I can still fit that. So I'm, blowing a little bit of time here for the sake of getting a better scale, right? So maybe I wouldn't have spent the time doing this. And that's why, before I keep going on this, let me just show you something else. If I double click on this and go to the drawing properties, underneath layout, there's a scale tab. And this is where I've got auto scales kicking in. And I've got some crazy size scales. Like a 50 scale for a really, really long rafter would make this look really tiny, and it would be very hard to see like kind of the flange lines and stuff like that if you printed this out on 11 by 17. Here in the computer, we can zoom in and see anything we want, right? Or if they had tablets out in the shop and they were viewing PDFs and the shop drawings on tablets, no problem. They can zoom in and see whatever they want, and you can make the drawings whatever scale you want. They can zoom into whatever detail. But if you're printing out on paper, and 11 by 17, sometimes these large scales are really hard to see. So I just wanted you to see that the auto scale is kicking in here when I have the shortening turned off, and that's why it was making the assembly view get even smaller. And I could turn this off and tell it to just do a very specific scale, but then I've got to work with the shortening. And so that's kind of the trade-off, is you can turn on those break lines, or if you leave this off here, then you just basically got to explain to the shop that, hey, this is a tapered member. There's no weird thing going on here. This is just showing break lines so we can get a better scale. And you just got to kind of work with the shop as far as what is the best kind of scenario that's going to be more effective for them to visualize the assembly at the scale or the way that they want the drawing represented. So otherwise, this looks pretty good. It's just cleaning this up just like I did on the column earlier, adding some dimensions, maybe just dragging a couple of these things down, like here to the hole instead of to the top of the plate. And then over here, this dimension, sometimes I'm not sure why I have the rule telling it to align, but it won't do that here sometimes. So I can just move this up. And again, if I just go back to dimensioning, I'll do parallel dimension here. I'll just click 2 points to define along that axis. And then I actually picked the wrong point there real quick, but let's just do that, and middle mouse button. Now, if this happens to you, right? Sometimes I love when mistakes happen, because then it just shows people, hey, what's going on there? Why did that happen? Well, the reason this happened is because there's this fixed property. There's free versus fixed. So this placing method down here in the properties. So when free is set, basically Tekla searches around the dimension to make sure it doesn't dimension on top of something else, like parts or part marks, based on the protection settings in the drawings in the view. Now, sometimes that doesn't do what you want it to do. Once you drag a dimension and move it to where you want, if I go back to that, it automatically switches it to fixed. So it's going to stay exactly where I picked that and position it. And so if the dimension settings have been saved away, like a lot of these running dimensions and things that are automatically placed by the drawing rules and dimensioning rules I've set up, they have this free set in order to make sure that they don't overlap with stuff. But then when I'm using those properties and manually putting in a dimension, sometimes it doesn't go where I want it. So I can just drag that and move it, and then it'll switch it to fixed. Now the other thing too is I'm going to match the properties. I don't really want a running dimension there, so I'll use the paintbrush, select on that, modify, and then there we go. And so then we'll drag that there, and let's just fix this to go to the hole. And looks like I even picked that there. I think you usually want the dimension there. And there we go. Now we got that dimension, got that all set. And in this particular case, I'm going to go ahead and leave the shortening lines there just so you can see how that works. But that shows you a couple of different scenarios how to deal with really long 3-plate assemblies and whether shortening is a good fit or not. Okay, so I wanted to save one of the coolest things that Tekla has for shop drawings last, and that is Smart Create or cloning and intelligent cloning. So what do I mean by that? Well, when I look at this building, pretty simple building. However, I had a situation here where this, walk-through door opening and the Girt elevations that was done on the building input, this wasn't originally working. And so just on this Girt line, we actually moved this up in Tekla rather than doing it in MBS, and just checked that with the engineer, see if that was okay. And so this particular Girt line is a little bit higher, which means that the flange brace clips are moved up as well as the Girt clips. So what did that do? That made this assembly different than the other ones. So if I click on this and I go ahead and say filter in the list, this is RF1-1. Now, let me show you here. I'm going to open this drawing up, and this is the one that I actually cleaned up. So I've got my section cut here, I've got my dimensions, I cleaned all this up. You can see that it's a little bit different based on like the very beginning of the video. So we're coming full circle here, and I'm cleaning up this column, and it's exactly the same column, just a little bit different because I actually changed some stuff in the model. So 7 foot 10 and 7/8, that's the running dimension to that clip on this particular column. I'm going to close this bad boy down. I'm going to go back into the model, and when I look at this here, what I'm going to do is I'm going to clear this off, and there is a very similar assembly to that at the bottom, which is the RF1-4. So if I click on this to select all those in the model, there's all the other columns. So it was just this one, due to that walkthrough door, it's just this one column that I had to make different and position the Girt a little bit differently than the rest of the columns. So it kind of segregated this out on the building. Now, with that being said, if I go into this RF1-4 drawing, you're going to see here that it's not too bad. This is just using the automated dimensioning, right? So just like you saw here earlier in the video with the master drawing catalog. Looks like there's cleanup that needs to be done though. So, it could take me 5 or 10 minutes to clean that up. Or what I can do is I'm going to see if cloning is going to work. So again, because I understand how metal building jobs work and what things might be similar or not, I know when it might make sense to smart create. However, Tekla also knows this. Watch this. I'm going to select on these drawings and I'm going to say highlight all the objects in the model. Now I'm doing that first because I want to remember that selection so that way I can tell Tekla to try to smart create or clone from those selected objects. I'm going to then delete these drawings out of the document manager. Okay, so I've deleted those out, and then now I can manually select on that assembly drawing there and say clone, and that's the old-fashioned way where you can kind of tell it what drawing you want to create these drawings from by manually selecting it and saying clone, but I don't want to do that. So what I'm going to do is I'm going to minimize this. I'll go up to create fabrication drawing, and when I choose that, if you have smart create on here, it'll automatically scan through the document manager of all the drawings you've already done, and it compares the geometry of the two assemblies and says, oh, hey, this one that you're trying to make drawings for is very close to this other one, and it has multiple assembly drawings that was done on it, including the web drawing. Let me just get rid of all those W drawings and by turning off parts here, so that way that goes away. And there we go. Now it's a little bit cleaner, and if I increase the size, you can see that it's cloning or wanting to smart create and clone from that RF1-1. So I'm going to go ahead and say, yeah, let's try that out. Let's see how that looks. So I'll say create. And then now, once that's done, I can go to my document manager and you'll see this message here that it says the drawings were cloned. So it did the 3-plate assembly drawing as well as the web drawing. Now again, geometrically, this is identical. The only difference is that the clip is moved up here, for the flange brace clip as well as the Purlin clip for this first, or sorry, not Purlin clip, sorry, the Girt clip for this first Girt. So let's go ahead and take a look at this. But before I do that, let me just go back to the RF1-1, and I want you to remember 7 foot 10 and 7/8, right? So then I'll go to RF1-4, we'll take a look at this, and here we go, 7 foot 2 and 7/8. So it looks identical, but clearly there is a difference here in the location of this first one. Now, when I open this up, when you do cloning or smart create, you do got to check things, right? You got to really make sure, because sometimes the smart create doesn't do a good job, and you'll see dimensions missing or kind of floating around. So you got to kind of make a judgment call and go, quickly eyeballing this, does everything look really good? But maybe I just need to move this down a little bit. But man, everything else looks really good. All my added dimensions, the way that I moved the marks, the way that I merged the welds, everything looks really tight here. My extra running dimension. So you saw at the beginning of the video the time it took me to clean this up from scratch. So this is the real strategy. So I want to close out the video with, this is how I train customers, okay? That you use a combination of the drawing settings that I've created as a good starting point, but then you know how your job is set up and what are the similar assemblies, or you can just use Tekla to do the smart create. If you know that you spend a lot of time, more than a couple minutes to clean up a drawing, then sometimes it makes sense to try to use smart create and delete the drawings that the automated rules did, delete those drawings and try the smart create out and see if it works, and it's going to save you time. Here I could save up to 10 minutes just smart creating and only moving one dimension and then moving on, rather than cleaning up the same drawing just because of one moved clip. Now, the cloning or the smart create doesn't always work. So sometimes this flips itself on its head and you actually burn more time dealing with the clone drawing and trying to find all the little things that might be wrong with it and fixing it versus just going back to the automated dimensioning settings and cleaning up the few things that you know you need to do. It's kind of like an art form to figure out that fine mix of what is going to save you the most time. It's all about productivity and getting the drawings out as fast as you can. Now, if that ever happens, let's say that the drawing was just complete trash, like the clone didn't do a good job. And usually where I see the problems in the past before like versions 2024 is I see like sections don't like move in the right spot, and then it doesn't dimension things and it kind of looks a little bit trashy. So if you ever have that scenario where you're like, oh, I'm going to abandon the clone drawing, I'm going to go ahead and just go back to recreating the drawing with the settings and then just clean it up. You just double click on the background, go to view creation, and you choose the recreate drawing. Yes. Press modify, you're going to get a message. It's going to say, hey man, you're about to lose all of your cleanup on this drawing that you had before. And so we intentionally want to do that. We're going to lose that. And now, instead of the cloning, you'll see that it uses the automated dimensioning, and then I got to go ahead and start doing my cleanup. So in this case, it doesn't make sense to do that because the clone did a really good job, but sometimes the Smart Create and the clone doesn't work, and you have to recreate that drawing, and this is exactly how you do it. And you don't need to go out of the drawing and delete it. You just come into the drawing properties, recreate it, and then start cleaning, and you're good to go. So I'll undo that back, and that drawing looks good. I can then go ahead and mark this ready for issuing. And then let's even take a look at the web drawing, right? You saw me do that earlier as well. And that took me some time. You know, there's some manual cleanup and things going on there. So let's look at the web drawing. Now, when we look at this web drawing, it should be exactly identical because the only thing that was different between this assembly versus the other one was the clip locations. So the geometry of the web plates and everything should be the same. The only thing that I see that's a little bit off here is maybe this slot mark needs to be moved down, and boom, 5 seconds, I'm done with this drawing, and I can mark it ready for issuing and move on, versus spending 5-10 minutes cleaning that up like you saw me do at the beginning of the video. So there you go. I know it's a little bit of a long video, and I went a little bit fast just because I was just trying to kind of go through this from a production point of view and kind of just show you some of the realities of what it's like to go through a job and to clean up drawings. But hopefully it gives you good perspective of some of the advantages of the good save settings that I have as a starting point. They're not perfect, but they do help you as a starting point, and some of the strategies to navigate how to kind of work through cleaning up drawings and dealing with different assembly drawing types. I'll finish off with that. There is one other level of automation that you can do beyond what I've shown here. Beyond cloning or Smart Create, as well as the automated dimensioning rules that you can customize and set up, there's also the Tekla Drawing API. And you can actually write automated dimensioning routines and drawing rules. Now this is a little bit more costly because it involves like a programmer, like such as myself. I've written these type of tools and things before, and I do these for customers. And so you can reach that other level of automation, but then there's just that trade-off on a little bit of additional cost and budget in doing that. But otherwise, here, if you're just kind of using our setup, you can see that using rules and Smart Create and cloning, you can get a job out pretty fairly quickly. It's never going to be as fast on a simple job as like MBS, but here, you know, on complex jobs or even on simple jobs, you can get pretty darn fast and pretty close once you have some good settings and a good strategy and process for creating drawings. Again, thanks for watching this video with me today. And if you need any help with your Tekla Structures setup or training needs as you get started, especially in the metal building industry, please feel free to reach out and we'll see how we can help you out.